Good morning. Well, at least it's morning time for me. Welcome to Flux Harmonic. I'm David Wilson, and today we're starting on day one of the Ludum Dare 50 game compo, which is basically a game competition where you try to make a game in 48 hours and see how far you can get. So it's going to be a weird stream because I think we're not going to have active viewership for a decent part of it, so I'm just going to be sitting here talking to myself, which is kind of weird, but whatever. So maybe I'll start getting a couple things set up and see if anybody shows up before I start describing what we're going to do today, and then we'll get started at that point. So let's see. I want to go. Well, let's just start up a file right now. Let's see, to do. Hey, Robert. Thanks for joining. Since Robert's here, hey Travis, nice to see you. Yeah, West Coast US is probably more possible to to be online right now. I think it's pretty late in East Coast. Okay, so folks are here. That's great. Thank you all for joining. I appreciate it. I'm gonna go ahead and start describing then what we're gonna do. First of all, let's take a look at the Ludum Dare webpage. So they've announced the theme. The theme is Delay the Inevitable, which sounds like a pretty cool theme because it can give you creative ideas to come up with whatever kind of game mechanics that you want that fit within that theme. And I have an idea in mind that we'll talk about in a minute. But I do want to point out that we have 1 day, 20 hours, and 49 minutes left, according to this countdown timer. Oh, is that even right? Yeah, 43 minutes left. So that's all we've got. And I'm not going to be able to work on this game nonstop over the 48 hours. So we're going to try to scope things down to the point where it should be achievable and see how far we can get with it. So let's talk about the concept for what I want to try to do. Before the theme came out, I thought, well, you know what might be fun is to try to make one of those top-down shooter-style games. I can't think of any good names of any right now, but let's see, top-down space shooter game. It's not going to be like one of those bullet hell shooters because, you know, that's going to put too much strain on my language and engine, but it will be, you know, one of the normal top-down shooters where you're in a ship at the bottom of the screen moving around, and then there's enemies coming down from the top in different waves, and you shoot them. However, to fit with the theme of Delay the Inevitable, what I'm thinking is that your ship is running out of energy. So while you're flying and trying to make it through the level, at the same time, your ship's batteries, or whatever storage they have for the energy of the ship for it to fly and to shoot and everything else, is gradually depleting. So the inevitability is that your ship is going to run out of energy at some point and you will die. But the question is, how long can you last until that happens? And then one of the mechanics is going to be how do you get more energy? Well, you can siphon energy off of enemy ships, but you can't siphon off of ships that you destroy. So the balance point is going to be deciding whether you blow up a ship or you siphon its energy. And, you know, that's just the sort of guiding design we're going to go with for now. We may change things about that later, but that's, I think it's good enough for now. It's a starting point that we can start building some code off of. Now, also, we need a name for this. And like I mentioned in the previous stream on, what was it, Thursday? Was that yesterday? No, the day before yesterday. I don't have sound support yet in the game engine, so I don't know if there's a way we can also work that into the proceedings, but since there's no sound, I was thinking of calling it something like name Silent Siphon or Siphon. I don't know. There's like a game called Siphon Filter with a Y in it. That sounds kind of cooler, but that might be what we go with for now and see how far we get with that name. See if we can have some fun just making a little concept off this. So maybe I will go with the SYFON because it looks cooler. So then with that in mind, what we should probably do is just get a repo started for this project so that we can start making some commits and get some basic code going. So we're going to go to the Flux Harmonic GitHub org, and I'm going to create a new repo. I think I'm going to call this LD50 silent siphon. An entry for the Ludum, whoops. And then I'm gonna make this public. Now my hope is that I'll be able to give you builds of the game as we go if you are running Linux. I had some trouble this morning trying to get my CI builds working correctly on the other game we've been working on. So I'm not sure how possible it's gonna be today. But tomorrow, I'm hoping I'll have that fixed so that tomorrow I can start pushing builds that you can try out. Okay. So let's go ahead and pull a folder up for that. I'm going to go into, well, let's try vterm, cd projects code, git clone, git at github.com, Flux Harmonic, LD50 silent siphon. Is that what I called it? Silent siphon. Okay. All right. Empty repository? Sure. There's at least a Git folder. That's good. Okay. So one thing we'll do is go and grab the project file from Crash the Stack. So if I go to projects, code, crash, I need to pull the latest on this, I think. Maybe this repo hasn't had many changes. Oh, I did some CI tweaks. Okay. So project.msc, this is our mesh project files. I forgot to mention for those of you who haven't been following, I've got my own programming language called Mesh, which is inspired by Scheme, and we're going to be using that for this competition, as well as my own game library. So let's see, we'll go to the LD50 and then project.msc. We're going to paste it in Scheme mode. I need to fix that. Silent siphon. Okay. We'll change a couple things here. Alex says, I'm going to be doing a lot of gross copy pasta. Alex is also participating in this event, so Alex and I will be talking about this stuff, I'm sure. LD50 silent siphon. All right. We definitely want these two dependencies because we need the game engine and the language compiler at the same time. And the rest of these config settings are good. The rest of this stuff is good. Main.c, I'll probably copy that over to link program. Silent siphon. Also do the same thing here. Silent siphon. Siphon. Okay. That should be good. Also, I need to go steal the, excuse me, the main.c file, or at least some aspects of that. Project. We're gonna make a source folder and then main.c. Excuse me. What else can I delete from here? Yeah, I think that's right, right? Actually, I might need that. Okay. Boilerplate main file. Now, should just try to build it and see what happens. I also need a main.msc file, so I'm going to grab a very short snippet of a main.msc file from Crash Stack. I don't know what the rules are on like just sort of grabbing the startup stuff from another project, but this is what we're going to do here. Okay, so if I go to the, come on now, I can't use some of my key bindings. It's going to kill my copy buffer. There we go. All right, so scheme mode, and I'm going to delete everything unnecessary here, just so that we start off with a more or less clean slate. What is that about? Alex says, some people call me Momo, so that makes it Mom Spaghetti. Okay. Windows show, we need that. We can get rid of these for now. Get rid, okay, I'll keep the current FPS. We want to see the FPS counter. And then the game updater parts here we need. And game renderer. So we'll clear the screen. We're going to make it just a black screen. This is Space Game after all. We may change that later. And no rendering of tiles. Also, I'm not sure about the rules on using fonts. So let's see. Oh, okay. Special exemptions for the compo. Compo is what I'm doing. Fonts are allowed. Great. So I don't have to worry about doing things by hand completely. Logo, intro screen, photos and recordings, content generators are allowed, textures, blah, 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 blah. Okay, fine. Good, good, good. I do need a font situation here. So let me go back to the crash the stack code. And then I'll go grab this line for loading up the bitmap font that I was going to use. And also need to copy that file over. To LD. All right. Oh, come on. Better to just do this inside of a folder or inside of a terminal. Crash stack, assets, fonts. No. Okay. So that's good enough. We should be able to get a basic screen rendering with that. And some of this stuff here, I'll get rid of. We do want to drain the input queue so it doesn't just get massive, but I'll delete that for now. I'll delete this for now, just to get into a very basic state. So we can start running this this file. So this file is now 53 lines. It's just the basics necessary to get a game running. Also change this to silent siphon. Okay, so I think I also need to copy the manifest file from Crash the Stack for Geek Shell so that I can use that for all the dependencies. So now if I run compile, I should be able to do this. Silent siphon. Oh, I need to get a build of the mesh tools also. Let's run this anyway. Okay. not crash stack, mesh lang CLI. I'm gonna grab the latest build of the command line interface for mesh, which should be interesting because we might see a lot of spew we don't want, but whatever. Okay, download this really quickly. Actually, no, I don't even know where these files are going, so I better save it somewhere that I can control. Interesting. Okay, so now, CD tools, unzip, downloads, mesh. Okay, cool. So then, all right. Now let's try that again. We're going to go into the root folder and run compile. And we'll see now whether this works. Have to download some dependencies. And then the first build and run of the game should work, hopefully. It's just going to download the mesh compiler, compile it, and then the Substratic engine, which is our graphics engine, basically. Compile that, and then compile the basic game code if it works. All right. Interesting. Okay, so that's why I took that stuff out of main, apparently. Let's do this again, because apparently this is a problem somehow. Modules main.msc? That can't be right. Yeah, I need to take this process launching stuff out of here because it's so distracting. Modules main.msc. I don't even have that in the code anymore. Do I? Where is that coming from? Oh. I did the wrong thing. It's this one. Here we go. This time it loads. And we've got our FPS counter showing on the screen, which is great. All right, that's our starting point. We got a black screen, window ready to go. So let's do some basic stuff like, so the approach I want to take, let's actually get a little bit more organized here. Let's keep our notes in a place where we want to be. vterm. I'm going to copy or move, actually. Did I get rid of that to do? Okay, yeah. So move to do to readme.org, I guess. Okay, so now just set this up a little bit. I'm going to do an initial commit for like the very first part of the game before I start doing anything else. So silent siphon, an LD or a Ludum dare 50 compo entry. And then I want tasks. All right. And also the strategy. Or a development strategy. So what I want to do is just get the sort of the basic game mechanics working as fast as possible. Because it needs to be playable. Why did the music stop? Oh, there it goes. So we're going to start with just like squares being rendered, I think. We're not going to worry about sprites yet because I'm going to have to draw some stuff later. But we just want to have something on the screen that gives us a sense that something is working. So After basic game mechanics, movement, shooting, siphoning, enemies or enemy spawning, etc. are working, we'll start making sprites for everything, but at a low level of quality, and I'm talking low, because I'm not an artist, but I am kind of interested in the process of trying to make something that looks halfway decent. For art, possibly stick with a 16 color palette of maybe reds and blues with a green accent, which sounds terrible, but I have something in mind for that where we might be able to make something that looks fairly decent with this. Now, I'm not talking about just red and blue only. I'm talking about like shades of reds and blues, or maybe like even more towards like a pinkish purplish or something. That way we have some color gradients to some degree and ability to do some better lighting and accents on the sprites. But I'm not an artist, so it's going to look like crap, but it's fine because this is a game development competition. It's not like it's a, you know, major game release or anything. And what else? After basic game loop is working, start adding new features to make it fun. All right, so tasks. Get basic player ship rendering and moving using keyboard keys. Implement basic shooting. Bullet particles. Implement, or let's see, add basic enemy spawning. Add basic enemy AI. Shoot. Well, shoot randomly. They don't really need to follow the player. They just need to have like a sort of predefined movement pattern. Or maybe not randomly, shoot at the player. Alex says, are you going fairly imperative to start? Oh yeah, this is going to be fully imperative. We're just going to do whatever works, basically. And since I'm using this language that I only started writing, you know, middle of February, we're going to have to probably add some features to the language and the libraries to make some of these things work. So we're going to be coding our ass off. All right, so that's good enough for now. We'll add more stuff later for the rest of this. So I'm going to check in what we have. Should probably also copy the getIgnore. Oops, crash a stack dot getIgnore. And maybe the get attributes. I don't have one. Okay, that's fine. So getIgnore, readme, assets, depths we don't need. Manifest, modules, project, source, and not tools. So let's go into .getIgnore and add depths and tools. Initial commit with basic working game program. Okay, and let's make sure that the repo has something. There we go. So we got all the basic stuff here. And the README is there. Good. So let's get started. Let's go draw some rectangles, I think. So in main, Do I have a function in renderer? Depths, substratic, engine, modules, render, no. Source, render.c. Let's see if I have something for draw rect. I do not, so I'll add one for that. So let's add a renderer draw rect function. And then swap buffers, draw texture. Yeah, I probably need actually an internal version of this that's wrapping, or that's being wrapped by an external function enmeshed, so I can have keyword parameters the right way. Let me think about this for a second. Nah, it's fine. Let's just do it this way. And for color, interesting. I gotta think about how I'm gonna represent colors. Let's just copy this. We'll figure it all out as we go. Draw rect. So we need the renderer. We don't need a texture. We need XY width, width and height. 0, 1, 2, 3, 4. And lastly, we need a color. Did I set something up for that? I don't think so. Let me think how I want to do this. I can just have a function for creating a color. I thought I had an RGB somewhere. Don't I have that? Main for crash the stack. RGB. No. Color. No. Apparently I never had that. I had something in Flux Compose, but I think that's old. So maybe it's not worth looking at. So we'll just create something new for Substratic in this phase. So maybe I need like a color.c file, or just keep it in renderer, because it seems to make sense to keep it there for now. Okay. So I can have another function for, let's say, RGB. I know it seems kind of weird to have a function called RGB, but I kind of like it just as a way to make it clear what you're typing in. So we're going to do that. I'll just rip this off. Okay, so now get rid of, I don't need that. I just need these parameters. So RGB, delete everything else. And then what I'll do, I don't like having a heap allocated data structure for this. Seems kind of jank to do that, but whatever. We'll start with it. Let me see. Do I return a pointer anywhere? Make pointer. Okay, good. I can steal that. So we're going to return a pointer. We're going to make a subst color. Color. And obviously we don't have a struct for that yet, but we're going to set that up. Now the question is, do I want this to be based on 255? Or 0 to 1? Get rid of these. I can also set alpha to 255 because I know I'll eventually want to have an alpha channel for this. Actually, maybe I do want to have it be RGBA to start with, because alpha could be used for like flashing the player whenever they get injured or something. Okay, so RGBA, let's call it. And we can also have an RGB, which does the simpler path, where it just sets this at 255. Okay, so let's go into the header for renderer. And we're going to make another struct here. Type def struct subst color. Let's go with floats. Float R. B. No. RGB. Okay. And that's good enough for that. So now we're allocating a color. Got RGBA, everything there. We're going to go add the RGBA function here as well. And then we're going to add this here. Okay, so now we should have the ability to throw a color in here. We were going into render into the rect function. So object pointer. So in the rect function, the last parameter is going to be the color. So 0, 1, 2, 3, 4, 5. Question is, should color be the first parameter? Or second parameter, I suppose you could say. Yeah, we'll go with last for now. Subst color. Color. Andrew. Yeah, it must be bedtime in North America right now. Okay, so pointer. Well, let's just do this. And drop it right here. Okay, do that. Probably could do the other thing here just to save some variable declarations. Get rid of that. Whoops. Get rid of this. So now, excuse me. Now we have the renderer pointer. We have, oh, I missed this part, PTR. X, Y, width, height, and then the color. What is that? Is that a monkey? Looking at the chat. Okay, so now we need to call render 2. Now let me go see what I have for rect. Draw, rect, fill, vec4 color. Okay, I think I can pass in a struct with those, but what is vec4? Ooh, maybe I should just go with vec4 instead. Vec4 is coming from CGLM. Excuse me. Color. Where am I putting that in? Floats. Okay, good. I think that should work because the struct will have the same alignment. So let's go with that for now. So if I call this function draw rect fill right about here. So do I have X, Y? Come on now, fill. X, Y with height color. Okay, same stuff. So let's just do this. Width, height, color. And this is going to complain, but we're going to cast it just to tell it, you know, do it anyway. So let's try to build this and see what happens. We're not actually calling it yet, are we? In main. Let's try calling it just to is it renderer draw rect? Okay. And we'll just go with an arbitrary position for now. The width and height will be 50. And the color will be RGB 0, 0 to 55. We'll just make a blue rectangle. Or maybe we can bump up these a little bit so that it's a bit lighter. And that should be okay. I don't like... Okay, let's do this also. Define player ship color. I don't want to be allocating and throwing away a color object every single frame. Player ship color. So let's do it this way. Okay, and we'll go into compilation buffer and try to run it. Okay, we got a crash. Dereference of a high value address, renderer.c, line 542. Oh, I forgot to pass in the renderer. So this is why I need type checking. Renderer. Okay, there's a rectangle. It's not the right color yet, but at least it's there. So maybe 50 is too small. How about 100? That's good. I mean, that's still small. 150, 150. All right, that's cool. We can also say define player X. We'll do this too. Define player size is 150. And we'll start breaking this off into multiple lines so that's not so ugly. And player X, player Y. Player Y, we're going to put it down, let's see, window height. Minus 200. And then define player X. Divide that by 2. And also minus player size divided by 2. No, wait. Yeah, there we go. Let's see if that works. Crash. Oh, no kidding. You got to give a window for window width. So he's somewhere off the screen. Who knows where? So we'll hard code. Wait, hold on. Wait. Player size divided by 2. Window width divided by 2. Ah, wrong. Backwards. Oh, actually, I can do this, I think. Yeah, there we go. There we are. Okay, so that's a decent starting point. Let me bump it a little bit more. Let's subtract by 300. That seems like a good starting point for our ship to be moving left and right. And I can move this stuff up above the game updater. Define some game state. Some of these things we'll put into like a record type or something else a little bit later. Okay, the color is not working, so why is that? I have the RGB. Did I pass it into the call? Yeah, I passed it in. Okay, so maybe there's something else wrong. Did I ever get yelled at about that? I gotta get all that process start stuff out. Excuse me. Probably doesn't matter, does it? I go to render.h, it's 4 floats in a row. And if I look at the default shader that's being used, Vec4 color, it's uniform. Oh, that's why. Okay, it's because I'm not using 0 to 1. So in my internal representation, I probably need to normalize those values. So then in renderer.c, right here, I need to divide by 255.0. 1.0. Same thing right here. Now let's try it. Still not the right color. Mem color true. It should be correct. Maybe I should dereference. So let's do this. Let's dereference color. I don't know why I didn't complain about that so far. What the hell is going on? Let's just check it out and see what we see. Color R, color G, color B. Make sure that it actually has a value. Something's wrong. Ah. Incompatible type. Expected float star, but argument is of type subs color. Great. Now it's starting to give me something that I expect. So let's call this a float star. No, wait. Hold on. That's fine. Float star. Let's do that. Oh, now it's rendering fine. Who knows, man? Okay, so now it's appropriately colored, which is good. It's a good starting point. Maybe I can go back into main and juice up the colors a little bit. Maybe like a 75. Let's go with 100. Just lighten it up some. Oh. Wow, how did it move down? Yeah, I bet I know why. The window was not the right height to start with. For some reason, my window manager sometimes likes to mess with me a little bit. Okay, so we got the rectangle drawing. I'm not happy with how inconsistent the FPS looks just from rendering a rectangle. That seems a little bit strange to me, but we'll go with it for now. So let's get ship movement working. If I go into main, we need to check the input. So controls, WSAD for directional, E for siphoning energy. Maybe, I don't know if that's going to be too difficult to hit. Space to shoot. Maybe we'll use the other hand, J for siphoning energy. We'll go with that for now. So we can start with the directional movement. And I guess the question is, I need to have like a controller state, because all we have in a way of input events is whenever buttons are pressed or lifted. So I need to have a state for certain movement directions. Excuse me. Getting over a cold, so that's why we have all the coughing. So let's see, maybe there could be an acceleration. If we do more of a physics style movement, then we can update that per frame. Okay. So define player vel x is 0 to start with. Velocity x, velocity y is 0. And let's see, define player move speed. This needs, hey Scott, nice to see you. This needs to be related to time step. And we're doing this based on seconds. So how many pixels per second should the player move? Let's start with 10. Seems like too much, maybe 5. Maybe that's slow. We'll go with 10. All right. And then we can have a function for define handle player input event. All right, so next event, input event. If input event handle player input event. And then now we're going to check the input details. And I'll go back to the main I have in Crash the Stack to remember how I set this up because I forgot already. So we're going to check. What was the other? If input key down, let's see. So we're going to check that first. Otherwise, we're going to check if input key, event key. That's going to be the else case. But if it is a key down, we're going to check to see which key it is. Okay. This is going to be some ugly logic, just letting you know in advance. Because I don't have any kind of case statement or anything of that nature yet. So we're going to be doing a lot of nested ifs, which is fine, I guess. Okay, so if equal... input event key code input event is W, then we need to set player velocity X, or no, Y. So player vel Y, player move speed. And we're going to do the same thing here. If equal... This is horrifying. Be better to have some kind of loop that I'm going through, but whatever. S, then we're going to set the... oh. No, I gotta do this. Set. Okay. I'm gonna give the reverse move speed. In fact, I think this is backwards. It needs to be negative for up and positive for down. Okay. Okay, let's see. That should be enough for the key down event, but what about the key up event? We need to basically just reset everything. This is going to be very primitive. Let's paste this in. Get rid of the previous. What did I just paste in? That was too much. Okay, there we go. So if it's a key up event and it's W, then we're going to... Oh, we also need to do this too. I forgot. Begin. All right. If you think key up input event, if it's W, then we set player vel Y to 0. Also, I could probably do an OR here and just do the same thing for the D key. So that will give us, oh, is this right? D, no, sorry, S. So maybe that will give us the right stuff to begin with. And also in the game updater, not only do we need to loop over the input events. Okay, so I think I need to have a function for this. It's going to get really ugly otherwise. Define handle input events. And that's going to be all of this nested let here. What does the winner get? The satisfaction of having won. I don't know. I'm not worried about winning. I'm just worried about like getting something working. All right, handle input events, and then we also need to update the player state. Player update. We have a function called that. Oh, and this needs to be reformatted. There we go. We'll see if I regret having all these function calls from a performance perspective. Okay, so for every frame, we just need to update the player position based on their velocity. So set player Y. Oh, we also need the time step. So do we have that? Time delta. Okay. Time delta. And for this, we can basically say the time delta is in seconds. So we can multiply the player move. Oh, no. Player vel x. If not equal 0, player vel x. Times time delta. Same thing for y. This needs to be fixed to x. Let's see if this works. Who knows? It might not. Ugh, it went too far. Who knows why? And it doesn't seem to be working in the other cases. D doesn't seem to be working anyway. Let me go check out, let's see. Scott says, how does the time difference affect your real job? I have a lot of meetings at night, which is not fun. Other than that, it's fine. Vel x, vel y. Okay, all that looks fine for now. If not equals 0, player vel x. If not equals 0. Let me, what was the FPS on that? Seems fine-ish. Okay. Very inconsistent. Handle input events. Excuse me. If input event began, handle player input, input event, next event, input take. Yeah, all right. If it's keyed down, printf. I need to get a little bit of a readout here because I'm not sure why it's not being updated correctly. Maybe I can just print it here. It's going to make things really slow, but it's fine. Display vel x. Just print it out, see what we get. Okay, so it is being set correctly, it seems. Whenever I press the buttons, I see the values changing. But the question is, why is it not moving correctly? So maybe I'm doing a calculation incorrectly. Oh, that's why. It's because I'm not adding it to the player position. Set player X plus. Yeah, here we go. That's the key. All right, let's see this now. Okay, it's moving. It's moving extremely slowly. 10 pixels per second. Is that why it's so slow? All right, let's bump that up to 100. That seems too fast, but whatever. All right, it's perceptible. Oh, why is it stopping? It's like moving in increments of 100, which seems wrong. Let's see. That's curious. I wonder why. But while we're here, we could also do the same thing for A and D. Let's make that D. And then here we will clone this and drop it under this. Horrible little tower of input presses. A, and then this one's going to be, let's just flip it, whatever. This one we're going to do -0. Player move speed. This needs to be A. Okay, let's try that now. Yeah, it's just going to keep moving. But that does tell me that something's wrong with the key events. Doesn't make a whole lot of sense. And then let's do that. If it's equal to A or D, then we're going to set the player velocity X to 0. Yeah, I must be receiving an event at some point that the key has been lifted, which doesn't make a whole lot of sense. Even 100 pixels seems too slow. Something must be wrong here. .300 pixels per second. Let's try that. Still doesn't seem very smooth, does it? I don't know if it's just because of what's going on my computer right now. At least it's moving. Let's go with 500. That feels more like what I would expect. Good. Diagonals are also working. Fantastic. All right. Well, you know, that's cool. Got some basics going on here. It's only been about an hour. But I got to figure out why. Oh, what just happened? Huh. So with certain kinds of button combinations, the movement keeps moving, which doesn't make a whole lot of sense. Maybe I got a bug in my code somewhere. How does it look on stream? Okay, actually the movement seems okay visually. All right. Scott says, any progress in the house buying? Yeah, we are getting close, finally. 500 pixels per second. I wonder if that even makes sense, calculation-wise. Because are we really moving 500 pixels per second? Maybe. Okay. So movement sort of works, which is great. Can we also add basic shooting, I wonder? Is it time for that? I mean, we can mark that off the to-do list in the README. Let's see. Ship rendering and moving. Yeah, we got that done. Basic shooting, bullet particles. So we're going to need an array. Well, it's going to be an array. Or a list. List is probably fine. Thinking about the data structure there. We add things to the front. Luvetti says, time to replace Nix with geeks. I give up trying to understand the Nix language. Yeah, it's not... I'd say Scheme is a bit better, but that's just my personal preference as someone who likes Scheme. Okay, let me think. For bullets... If you shoot a bullet, we need to add it to some kind of data structure, like an array or a list. And whenever the bullet makes contact, it needs to go away. So we need a way to remove them from the list whenever they're no longer relevant, like they go off screen or they hit another player or another entity. And if I have a normal const list, then I could possibly remove them, but I need to factor that into the algorithm. So we can go with that for now. All right, so we can have define player bullets. Start it with an empty list. And then for each of the bullets, we want to render a rectangle for it. So what if I just start off with, let's see, define record type bullet. This is our first little record we're going to deal with here. Fields, X, Y. That's all we really need for now because we'll just do static position updates. We might need a speed though. Vel X, vel, well, let's just go vel Y for now. And then for the list, I have a list function, make bullet, X, 100, Y 500, just so we can see it on the screen and try to see what it looks like when we draw it. How about this? 600, and then the vel y is going to be negative 200. I don't know. So we're going to hack this in, and then we're going to make it work the right way. Let's see. Define bullets. Probably should start breaking these out into modules in a short time here. Time delta. So let next bullet. This is a typical scheme loop here. We're gonna have bullets. Well, I have player bullets, but honestly, it needs to be bullets in general. So owner, we need an owner of the bullet. So the player is the owner of the bullet, I guess. Everybody's hacking on the weekend. That's right. Best time. So we're going to have just the bullets list. Bullet list. So bullets, bullet list. And then if pair bullets, then we're going to do the thing. For rendering, we just want to go and render a rectangle, basically. Regular old white rectangle. Or maybe yellow. Let's go with yellow. Orangey, yellowy. Okay. Player ship color. Bullet color. Does... What about like a light orange? FFA500. I wish they would give me that in RGB. FFA500. I think DuckDuckGo or... Yeah, here we go. 255, 165, 0. Oh, whoa, 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 whoa. All right, here we are. Bullet color. That's for render bullets, bullets render, whatever. All right, let's just have a better naming convention here so that it makes sense. Render bullets. Bullet color, let's see. I don't want to do a let here. But calling car a million times also isn't fun, so maybe we should just do this then. Let bullet is car bullets. Get rid of the begin. All right. So bullet X, bullet, bullet Y. I think we'll just say bullet size, and maybe those can be 50-50 for now. Bullet color. Oh, goodness. All right, render bullets. Waiting for the notification to pop up on my display here. Ah, R Primus. Thanks for following. Nice to see you. So cool, that's good. And then at the end of this, I want to call next bullet. That needs to be in the let. Next bullet, cutter bullets. There we are. Render bullets, that should work. Render bullets. Renderer. Need the renderer. I don't need time delta. Let's see if this does anything. No. Bullets update. Update bullets. Time delta. We're going to do the same thing. And if it's a pair, we're going to do a let, bullet, car, bullets. It's just the same thing here. We're just going to update the position based on, let's see, bullet Y set bullet. And we're going to update, excuse me. I need to do this only though if the velocity is not 0. So if not equal 0 bullet vel y bullet. Well, no, it should be okay. Never mind. It's always going to have something. No bullet. A bullet's not going to just sit there. Bullet y set bullet bullet y bullet plus bullet vel y times well, no, that's right, isn't it? Time delta. And then lastly, inside of the let, I need to call next bullet with cutter bullets. All right, let's see what happens. Okay, bullets, update, update bullets. Crash. Oh, hold on. Record field access for type bullet. Let's see. Bullet X. Bullet Y. Bullet vel Y. Okay, there we go. We got to pass in the bullet. Hey, it's moving. Boom. All right. Let's make it smaller. I think that's too big. How about 20? And it's moving kind of slowly. So how about make bullet 700? That seems better. So now we need to make it so we can shoot them. And then we also need to remove them from the list if they are no longer relevant, which means kind of need a way to filter them as we're iterating. So we need to return. Yeah, okay. We can do that. Update bullets set bullet list. So in update bullets, we can then drop any bullet that is no longer relevant. Yeah, we're getting somewhere. Okay, so in update bullets, now we're going to be building the result list at the same time. So what that means is that every time we call into this, if pair bullets, then in this logic, so right now this makes it tail recursive because we're just going into next bullet. If I change how this operates, we need to be pushing down the new bullet list, I think. That's the thing here. So, new bullets. To make this properly tail recursive, we needed to like feed forward the new bullet list, which means that the order of the bullets is going to be flip-flopping every time we run this update function, which is going to be a lot of fun. And we're also going to be shedding constants like crazy, but whatever. We'll see what happens. To those of you just joining, we're making some progress here. We actually have some stuff on the screen and a ship moving around, and we're getting to the point where you can start shooting bullets. So let's see how that goes. So new bullets for every update. We're going to check and see if the bullet is still on the screen. So we're going to move the bullet. First of all, move the bullet. Check for collision, which we're not going to do yet. Check if bullet is off screen. So I think the easiest thing we can do here is just to see if bullet Y plus bullet size. If bullet Y plus bullet size is less than 0, top of the screen, then it needs to be removed. Or how about this? Greater than 0. Because that's what's going to cause us to update this bullets list. Set new bullets, cons bullet, new bullets. That might be enough. Still on screen. Okay. So we'll check for collision a little bit later. So that should be okay. And what I'll do here is just add a little display to let us know that we're removing it. So begin display removed bullet. Let's see what happens. Uh-oh. Expected 2 arguments got 1, line 110. Ah, right, okay. Yeah. Okay, that's good. Removed bullet already. That seems wrong. Oh, no. No. Const bullet new bullets. Oh, and then at the end, I need to return that list. So if it's not a pair anymore, then we need to return the new bullets list. There we go. So let's actually change this. I don't want... Okay, there we go. This should work. Boom. All right. Kept bullet? No. All right, so removed bullet. All right, so it's moving and it disappeared off screen. So that shows us that bullets flying do get removed. They get deleted from the list. What's the FPS right now? Okay, still fine. Good. So now what we need is to enable the player to shoot bullets by pressing a button. So let's go into modules, substratic, input. We need to add the key code for spacebar. We should also add J while we're at it, I think. So GLFW input reference space. Where are the key definitions here? Key code. See also key names. No. 65. It's not in this list. Key code. Code. Scan code. Okay. All right, let's click this one. I think that's what we want. Space. Key space is 32. Oh boy. Spammers. There we go. Okay. Got rid of the spammer. All right, input key code space. So what we'll want to do is go back into main, and we're going to go to our input handler. And then another thing we're going to do for key down. We only care about key down for this button, which is good. So I'm going to press copy right here, and then we'll drop this in, key code space. Maybe I need a function for shooting a bullet. I don't know if anybody's talking from Twitch. Let's see. Because I can't see any chat being brought across. Okay. Looks good. All right, so we have input key code space. And we're not going to set velocity, we're just going to shoot a bullet. So let's have a function define shoot bullet. Kind of need a entity position to start. Oh yeah, that was coming from YouTube though. In fact, Alex, let me add you as a mod here also if you want to be. All right. Input key code space, shoot bullet. I'm trying to think of like the right way to get this going. Because we're going to need this as a general feature because, you know, the player's going to shoot, but the enemies are going to shoot also. So we needed the enemies to also have the ability to do that. Alex says, I don't like that tone on even you. I don't know what I said. This is all stream of consciousness. Don't take anything I say as a real opinion. Start Y, or let's just say X, Y, and then vel Y. Let's just do that. That's how we're going to start this. And we will do this by saying shoot bullet. Do we have the player? Yeah, player X. We want to shoot from the center of the player in the X. Well, do we want to do that? I guess so. Let's just go with that for now. Maybe we'll have different start positions for bullets later when we start adding other weapons. If we get that far, we'll see what happens. Player X. Plus. All right. Yeah, player X plus player size divided by 2. That should be good for an X position. For Y position, it will be minus player Y and bullet size. Thanks, R Primus. I see your message coming through. Okay, so that is the good starting point for this. And what was the other? I think I used like negative 700 or something, right? Default bullet speed times -1. Or we could just do 0 minus default bullet speed. Where is the bullet stuff? Define default bullet speed is 700. All right, and now we don't need to do this anymore. We're just going to take this out. All right. So if I do shoot bullet, then I need to mutate the bullets list. Let's say set bullet list cons make bullet x x y y vel y, vel y. And the old bullet list. Probably need to have a way to cap off the amount of times they can shoot if they keep holding the button down. Ah, yeah. Okay. We're going to have a crap load of bullets. Actually, it'll never stop shooting. That's what's going to happen the way that I got this implemented. That's fun. All right, let me think about this for a second. Oh, no, hold on. Only when the input is received. Okay, this should be fine. I think that's good. Let's try it, see what happens. Boom, 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 boom. All right, we're shooting bullets. Look at that. I like it. What do you think? But then it requires you to keep pressing space repeatedly. Okay. And, I mean, the FPS seems like it's still working pretty well, despite the fact that I've got some stuff going on. Cool. All right. Let's check in some code before anything goes horribly wrong. And depths, substratic, engine. I need to check in something here. Is the FPS always going to be variable? Hey, Daigo, thanks. Is the FPS always going to be variable? Well, it's going to be. I don't know. I don't know if I'm just calculating it wrong or if it actually is that wildly different. Hey, Felipe. Okay, so let's check this stuff in as well. Renderer, add, rectangle, drawing, and color functions. And also, we probably want to add the code for J, key J, since we're going to need that too. I mean, I should probably add all of these. Can I just do this and then clean it up? Let's get all the normal keys in. This is going to be fun. You know, actually, it's defined, so maybe I could just go through here and do a little cleanup to fix that. Not going to spend much time on this, just trying to get some things in case we want to use any other buttons for actions later. All right, so then these are all going to get changed into open paren. And then we're going to go through and... oh boy. The hell? Just paste it verbatim, dude. Okay, let's turn off Lispy mode for a second. Or is it Lispyville that's going to cause a problem here? Yeah, let's try this. No, Lispy mode. Let me paste. A great opportunity to use evil macros. Yeah, it would be. Oh, here we go. Finally. Gotta delete that crap off the end too. Okay, here we go. Let's get this stuff off the end of the lines. And I'll... and I gotta change all my my name constants too. That's fun. Replace regex. Yeah, I'm gonna have to do that. Let's see. GLFW key. Let's do this. GLFW key underscore to input key code. Also need to lowercase all those. What's the lowercase button in evil? Vim lowercase u. Aha. GU. Thanks, Divest. Tilde. I guess tilde could work too. Equal. All right, it's not wanting to clean this up for me. Is that because I turned things off? Lispyville mode enabled. Lispy mode disabled, enabled. Okay. Yeah, there you go. Clean it up. Do your job. There we go. Okay, so now I can get rid of the other WSAD defines. I gotta add exports. Fine. Okay. Go back and delete all that. We're going to put that right there. That should be good enough. Let's run it again. Okay. These still work. Good. Normal S. Yeah, I should probably learn some more stuff here. Obviously, doing things the inefficient way, but that's fine, you know? We got it done. Okay, so add more key code constants to substratic input. I don't even say that. I need to change my remote for this. Git at github.com :substratic /engine. All right, push to. Oh no. Don't do that. Okay. And then, did we already check in? What am I doing? The code here? Nah, okay. Everything good? Yeah, all right. I like it. Initial, let's see, draw player rectangle, basic movement, basic bullet shooting. Then what do we have in our README for tasks? Basic shooting. Okay, yeah, that worked. Basic enemy spawning. Maybe we can do that. But first, I'm going to take a break for about 2 minutes. So let me see if I can pull up my be right back screen, which is going to look hideous. So I'll be right back in 2 minutes, okay? See ya. All right, we're back. Good morning to Jens. Our Primus says, where is the mesh repo? It is at github.com/mesh-lang compiler. That's mesh is basically scheme, just with the letters shifted by a couple letters. So it's easy to find that way if you are looking for it using the scheme spelling. Alrighty. So basic enemy spawning. This is going to give us the ability to shoot something, which will be cool. So how about we get started on that? We probably need to get into some, modularization of the code at some point here because it's starting to get a little bit long in this file, but maybe we'll just wait for a minute before we start doing that. I hate this function so much. This is terrible. I really need like a case implementation. I was waiting to implement macros first before I did that, but I don't know how soon I'll be able to get macros implemented. Or at least syntax case, etc. from Scheme. All right, so we want enemies. Maybe this is a good point to make a record type for an enemy. Now, we're going to have different enemy types. Let's just think about this for a minute. Record bullet. Okay, so enemies, bullets, and then here we can say player, just to keep a little bit of cleanliness. Can I do 3? Okay, there we go. Yeah, that's what I want, actually. What the hell, man? Come on. There we go. Like, you kidding me? I joined the line. No kidding. Can I put another one in without it doing that? All right. So for enemies, varieties of enemies. Plane drones that fly. I think, I mean, flying in a straight line is pretty dumb, but maybe that's the idea. Fly in a straight line or at an angle. Also, enemies with a more fluid movement path, like probably based on sine waves or something like that. Whoops. We may have to find some inspiration for what these could look like. And let's say we could have enemies that fly in a formation. That's probably good enough for now. So if we define an enemy record type, define record type, enemy, fields, we still need X, Y. Now, we might need to have some kind of function for deciding the movement pattern. So, the enemies aren't going to try to track the player. Well, they may not try to track the player. They could. Okay, so how about this movement func? We're going to pass a function to it that will control the movement. So that will give us the ability to do different movement for different enemies. X and Y position current. And anything else that we need. I mean, you could have like a health counter, I suppose. Maybe. Or a shield. What else? And for now, we'll probably want to have a color until we have actual sprites. Once we do have sprites, then we'll have a texture instead. Maybe also like a rotation. So maybe instead of a movement func, this is going to be an update func because we may need to do other things as well. And then for plain rendering, we'll just have one function for rendering. I think that should be sufficient for now. Okay. So what we could do is have some functions for making different types of enemies. So for instance, make drone enemy. Or maybe this is more like a spawn drone. How about that? And we can also have an enemies list, similarly to how we have a bullet list. So define enemies list, or enemy list, I guess would be the right way to say that. Enemy list. Have it be empty at first. So we're going to spawn a drone. We're going to make enemy. And then what we need to do is spawn them just outside of the screen. Maybe we also need a size here too. And maybe, well, we'll deal with size X, size Y another time. We'll just have size for now. How big is the player? The player's 150. Okay, so maybe the drone can be a size of 100 for now. X and Y position, let's just start with a fixed position for that. So X is 100. Y is, let's say, 0 minus, well, yeah. No, we could do negative 100, can't we? Yeah, negative 100 for now. And then color is going to be RGB. Let's see. What kind of angry color can we make for an enemy here? We can go back to, do we have that color picker still around? Cool. Let's go to like a more, well, a drone is kind of stupid. So what's a stupid color? Let's go with this kind of a reddish thing. 255-081. 255-081. All right. Maybe it's a little bit too aggressive. How about a light green? Greenish yellow. 234-255. 234. Okay. And we need shield. Drones should be very easy to kill. So let's say a shield of 10. And then update function. Let's see, we have shield color size. And then update func. Define update drone time step. And we'll put that in. Update drone. All right. So, update function. Really, we just want to update the Y. We want to make them fly down. And maybe at some interval, they should shoot a bullet. So then what we could do is set, enemy Y set. Let's see. We want to set their position to, we don't have a speed. Well, that's okay. Let's just do this first. Times, 400. Probably should have a function for updating things based on a velocity because this is starting to get repetitive. Enemy Y. Wait a second. We need to have the drone as the first parameter. Update drone enemy time step. Enemy Y enemy. $400 times time step. Okay. That should just move them. So that's probably enough for now. And we don't need to return itself. Okay, update drone, spawn drone. Cool. So that should actually be enough to make things happen. So let's go down. Maybe we need an, let's see, define update enemies. Time step function. Update bullets. We're going to rip off the update bullets logic a little bit here. We're also going to call set enemy list update enemies time delta. There we go. Same concept. So if we copy this, we'll take this whole thing, paste it in. All right, so we'll just do some renaming. Next enemy. Wow, hello. This bee is biting me again. Enemy, enemies, enemy list, new enemies. If pair enemies, enemy. Ah, come on. Who knows what I just did? Probably should just be doing find and replace. Okay, so update the enemy. And probably should do collision checking as well, but we're not going to worry about that just yet. Check if enemy is still on the screen. Enemy Y plus do I have a size? Yeah. Enemy size, enemy. So we're going to have to deal with sort of playable game area at some point soon. But for now, we'll say it's going to be the window height. But yeah, we're going to have to do something about that very, very soon. So if the enemy Y position plus its... No, just that. Just the enemy Y position, because we want it to be off screen. So enemy Y plus is greater than window height, then, or let's say less than window height. Then we say new enemies. Come on. Enemies. Cons, enemy, enemies, right? Removed enemy. And then we'll say new enemies. And then next enemy. All right. And then return the updated enemies list. New enemies. Cool. That all looks good, but we still need to call the update function. So we're going to call the enemy update func for the enemy. We're going to pass in the enemy itself, and then we're going to pass in the time step. Enemy. All right, so now let's try to... Wow, why don't we have a gal REPL? Compilation buffer. Let's run it, see what happens. Okay, so I haven't actually spawned anything yet, so we'll go spawn an enemy first. And maybe I need to do some randomization to figure out when I should be spawning new enemies, but we'll just spawn one to start with. Spawn drone. Would be nice to have a random value here. So what if I do rand int and modulo that with... I have modulo operator here. Rand int modulo window width window minus 100, which is the drone size. So we're saying take a random integer and then put him somewhere inside the window width, but factoring in that his size should not be outside the window. But maybe we'll change that at some point. Okay. I'm just going to go down here. Spawn drone. Let's just spawn a couple of those. See what happens. Okay, something wrong. Rand int function requires one parameter. What is it? Let's see. We'll go to deps, mesh, compiler, source, math. Rand int. Why did I do that? Oh, I'm just giving it the modulo to start with. Okay, well, that's fine. I mean, that's sort of what I want anyway. So rand int. We'll just take that out. And do that. I don't see anyone yet. That's because I didn't actually add it to the list. So const make enemy, we'll join that line, and then we'll go down here. We're going to const that with the enemy list. All right? Okay. Where are you? Let's see if that shows up. Okay, so something is not working. Oh, I haven't added the render enemies. I'm not even rendering them yet. That makes sense. Render the enemies. Render enemies. Renderer. Okay. And then I also need to update the enemies in the update function. I'm doing that. But it doesn't seem to do anything, though. Update enemies. Display added enemy. Okay, fine. So where is update enemies? Now we're going to do define render enemies. Renderer. And we're going to copy the loop slightly. We don't need this part. Did you just break everything? Yes, you did. Good job. All right, we don't need new enemies. Render the enemy. All we'll do is just render a rectangle for now. Draw rect. I'm just going to go right here. Render the enemy. So this is going to be enemy X and enemy Y. Okay, and then we'll say enemy size twice. And enemy color as well. Okay. We don't need that. Or these. Okay, and then we'll take this new enemies out. All right, let's see what happens. Still no updating or rendering. Let's see, spawn. Do I have a list length function anywhere? Let's see, math. Let's go to list length. No, I don't. Oh, I can just print it. How about that? So main, I'm gonna say display enemies. Empty list. Wait. Oh, is update enemies doing something wrong? Can't be. Enemy list is empty. Oh, pff. Gotta do that. I think we're done with that. Okay, that seems good. And this error, record instance. Okay, good. That seems right. We can delete that now. Then in update enemies, enemy Y. Missed something somewhere. Update drone. Ah, there it is. And let's get rid of that too. There it is. We got two enemies flying down. And then we remove them from the screen. Okay. Cool. They're moving a little bit fast for my taste. So where is vel Y? Oh, it's in the drone function. Update drone. 400. Okay. Let's say a defined drone speed is 300. They should be slow. Thanks, Alex. Yeah, we're making progress. Done speed. Drone speed. Cool. That's more like it. It's not so fast. Could even bump it down to potentially 250. Yeah, there you go. That gives you some time to shoot at them. Let's think about this for a second. Alex says, I think I've designed my game and I'm going to get the base code going. Awesome, dude. Okay, so we updated the drone. The drones should shoot at some interval, maybe. Not necessarily a predictable interval, but at some interval. So the update drone function is where we would have that logic. Update position. And then, is it time to shoot? Let's see. Well, maybe it's not even time to write that part yet. What would be more interesting is coming up with a randomization function for spawning enemies so they show up every now and then. So let's see. We make it on a specific time interval. I mean, you could say like on every frame there is some small chance that a enemy could be spawned, but I would actually like it to be more time-based so that as you play longer, the likelihood of more spawns happening more frequently increases. So maybe there's like a spawn interval that gradually ramps up over time. So after some certain amount of time, we decide to spawn something. So like, let's say 2 seconds, and then we gradually shorten that interval to like, you know, half a second over the life of the game to make it more difficult. This is not going to be, you know, a very advanced system, I would say. This is going to be, you know, something that works. Gonna eat some gummy bears here. I think I could probably adjust the rate for this. So the base spawn interval could be the range. So half a second. I mean, that would be nuts. I think half a second, the enemy shows up every half second. But that's what we're gonna go for. And then interval range. What would we want to say? Like 4 seconds. Every 4 seconds, an enemy could appear. So we start off with an interval range of 0.5 to 3.5. Okay, and what I'm gonna do a little calculation based on these effectively. Define enemy spawn interval. It's sort of like the 0 to 1 value scale. We're gonna basically go from 1 to 0. We're just gonna, you know, gradually tamp that down. over the life of the level. Okay. So now we can have an define update spawns function, or spawn enemies, I guess we could say. Check for spawns, I guess. And time step define enemy spawn time is 0. We'll start at 0, and we're going to add to that based on the check for spawns here. So set, what's it called? Enemy spawn time. And we might spawn more than one enemy every spawn, every instance of a spawn. So we could make a decision on that also. We might have actually different functions that we call for spawning. So you could spawn like 3 enemies at once if we wanted to. Okay, so it's set enemy spawn time plus time step. Enemy spawn time plus time step. Okay, so now we've got that. If greater enemy spawn time than the enemy spawn, what was it, interval base? And also we're going to multiply that by the enemy spawn interval range. Enemy spawn interval range by the enemy spawn interval. Welcome to Zion7. Thanks for following on Twitch. Okay, range times scale plus base. So our range is 3.5, our scale is 1.0. We're gradually going to decrease this scale over time. Excuse me. And we'll decide how to do that a little bit later. But for now, well, honestly. So let's change this just to make it every 1 second somebody spawns, just for testing purposes so we see it working. All right, so we're setting the enemy spawn time. If it's greater than the value, then first of all, what we want to do is reset the spawn time. Set enemy spawn time is 0, and then we want to spawn something. For now, we can just say define spawn enemy, and that could just call spawn drone. Spawn drone. But later, it might spawn different types of enemies whenever we have those figured out. Okay. And yeah. So if we call check for spawns inside of our update function, game updater, first thing we can do is say check for spawns time delta. Okay. Let's see if this works now. All right. Seems to be working. It's spawning things based on the time delta that I set. I did make that smaller for now. So we've got some dudes flying down here, which is cool. Let's take out these 2 initial spawns because we don't need that now. All right, there we go. Now I can dodge these if I want to. Okay, so now what I can do is go and change back that value right here. Delete that. And then it should be like 4 seconds between spawns. So we're just kind of chilling for a little bit. And then all of a sudden an enemy will pop in. And then after a while, another one will pop in a little bit later. Probably, yeah, there we go. So even that is pretty frequent and maybe a little bit too regular to start with. I might need to augment that slightly. Okay. And the way that I can do this define total level time 0. So every frame, I'll update the total level time. And what would we say the maximum level time would be? How many seconds would we want that to be? A minute? Or potentially 2 minutes, 180? So what we can do is adjust that value every frame of the scale. In fact, we don't even need the scale value if we can just calculate it every frame. So I can say in the updater, set total, what was it called? Total level time plus time delta total level time. Okay. So if we have total level time, count how much time we've been in the level. Update the player. So once we have the total level time, in the check for spawns function, the scale can actually be the total level time divided by the max level time. Then we can get rid of this. And that should actually cause this to change over time. Things should start spawning more quickly as we go. Let's see if it does. Oh, that's too often. I probably need to reverse that value by subtracting it from itself. So minus max level time. Hold on. Wait, let me think about this for a second. Total level time divided by max level time. Maybe I just need to flip the division. So if I were to divide, excuse me, my voice is cracking, by 175.0, 102. Is this, oh, I think this is what it is. Minus max level time. Minus, yeah, okay. So if we say it's the max level time minus the total time, starts off at 0, and then we divide it by max level time, then gradually this number will get smaller, and then that will make the scale value smaller, which will make the range smaller. Okay. I think that's the trick. Okay, that seems right. So it's about 4 seconds for the first one to come in. And they're still fairly slow. It gradually seems like, you know, more are popping up. And I can try shooting at them. Boom, boom, boom. Doesn't do anything yet. Need to do some basic collision detection. But, you know, we've got something that looks like it's, you know, a game that's doing something. Okay. Now I can take out these statements for removing enemies and bullets. Removed enemy. Let's take that out. Removed bullet. Let's take that out, just so we don't have any spam. Okay. So I'm pretty happy with that so far. And we can try to implement the end-to-end game logic before we start adding more enemy types. So obviously one aspect of game logic is shooting the enemies and making them go away, right? Another is siphoning energy, because like we were saying, the concept of this game, in fact, Delay the Inevitable, I believe, is the name of the... Oh, I have two windows up in here. Delay the Inevitable is the theme. So let me go back to the readme.org file. The theme for this Ludum Dare is Delay the Inevitable. So the way we're delaying the inevitable in this game is that your ship is running out of energy. So at some point it's going to run out of energy completely, and then you lose effectively. So how long can you last until the ship runs out of energy? You do that by siphoning energy off of enemy ships, or potentially even drops of energy that will come through as you play. But you have to decide between siphoning off of enemies or destroying them if they get in your way. So you have to balance out which action you're going to take at any given moment. So shooting enemies and then siphoning energy from enemies. It does also mean we're going to have like a shield meter and an energy meter. We could start drawing that really quickly as something to do. All right, so player. Let's go to where the player stuff is. Define player shield amount, 100. Or we could say 1.0. Define player energy amount, 1.0. Okay. And then we're going to use that to draw meters. So for the energy meter, we're going to say maybe a green color. We can draw a bar for that. This will start looking like a game real soon here, I think. We're going to draw everything after. This is on update. This is on render, draw rect. Oh, this is the bullet drawing. Let's move these functions. This render bullets and update bullets needs to go up into the bullets section. All right, so then bullets. Here we go. Player update. Update player. And we'll move this stuff too. Go to the player section. Just clean up the code slightly. Okay, right there. And then handle player input. I'll move this over to the player section. Input. Game loop. All right, so we're going to go up to the player section and dump that. Okay. Make sure the game still runs. I think I may have changed the code somewhere. So yeah, it probably crashes. Player update, update player. There we go. Okay, everything seems to be good still. Our enemies are spawning. Spawn and update enemies. Update bullets. Actually, we should update bullets first, maybe, so that we can do collision checks. Yeah, everything's still working. Okay, maybe I'll check this code in so that we don't lose anything. I don't even remember what all I added here now. The last commit was draw a rectangle, basic move it, basic bullet shooting. Okay. So add enemy spawning at an interval. Rearrange code bit. Gonna push this. We also, excuse me, also got basic enemy spawning done. Now what we're gonna do is add shield and energy meters. Add bullet collision detection. All right, that's good. So we'll update the README. Let's double check that all this stuff is getting pushed. Okay. Got it. So now let's go and put the meters on the screen. I think we can get this out of here now too. Render the bullets, render the health and energy meters, or shield, I suppose. Okay, so draw rect, we're gonna do that. This is gonna be, let's see, we're gonna draw 2 of these. And the position and size is relative to the scale of the value. So if I were to say what the X would be, so let's say we want the meter to be, meter is 200 pixels tall, 50 pixels wide, okay? So 200 minus player shield amount times 200. All right, so we need a value for the meter height. So shield amount, maybe we can say here, define meter height. Define meter base. Let's not do that. We'll just do it directly. Meter height is 200. We can even have a HUD section, maybe. How about this? Let's go right here. Okay. And all this stuff we're going to have to break out into modules at some point, but I'm not going to do it quite yet because we're making a lot of progress just with editing this file. All right, meter height 200. So we can start doing some calculations here. Let shield meter height shield meter height times player shield amount times, I don't need to do this, do I? It's just the height times that. Okay, so let's do this. Player shield amount times shield meter height. Is that, what do I call that? HUD. Meter height. Okay, cool. Yeah, there we go. All right, shield amount times meter height. Now, we have the meter height, and we can try to render it based on that. So we want the base position. Let's say window height window minus plus meter height. No, yeah. Yeah, let's do this. So we need, okay, let's hard code something first. Well, no. Okay, window height minus 300. Let's just say that. Window height minus 300 minus shield meter height. That's the start position. And then we're going to say shield meter height here. Shield meter height. Meter width is going to be 20 pixels. The X position is going to be, let's do that, window. Window width, window, minus 300, let's say. I don't know. And yeah, player away, take that out. So let's just do this one first. Player ship color, we'll just leave it for that for the moment, and we'll fix it. Let's just see if this draws anything. Okay, so that is something. Let's make this potentially 40 pixels, I'd say. And also the position of this, let's say minus 100. Okay, that's a little bit better. 200, make this 30 pixels wide. All right. Yeah, 40. And make it a little bit taller too. And we also need to give it its own color so it's obvious what it is. So meter height is going to be 300, let's say. Whoa. I like that better. Okay. We can also change the amount of position from the bottom of the screen. So how about 100 for that? See how that looks. All right. Yeah, we definitely need to establish a playable area. Like maybe this whole right side can be the HUD. And we can also duplicate this for the energy meter. And let's do this. Shield energy. Yes, yes, yes. Okay. And the meter height, we're going to say define energy meter color is RGB something. Same thing for shield meter color. All right, so we'll go back here. For shield, I'll pick like a light blue of some sort. Like that. That's going to be 158, 252, 255. And for energy meter, maybe like an orange. Something a little bit more rich. Okay, then that could be 255, 105, 41. All right, and then we can go back down here and then set those up. So for the energy meter, I'm going to make this be 50 pixels away from the side. But that still needs to be adjusted, so I think we're going to have to do some more calculations. Wait, hold on. That's wrong. Not that position. It's going to be this one. 150. $100. Okay, all right. So this is energy meter color. How about that? Energy meter color. All right, and then we're gonna do shield meter color. Okay, we got two little meters here. Maybe we can adjust the positions of that slightly. 150. And this will be 100. Now maybe you want to give them a little bit of space in between so they're not so jammed up together. So maybe this could be 90. Let's put them a little bit closer together because I don't like it too far apart. Okay. How about that? But the thing is, we need to not have the player draw under them. So we're going to have to do a little bit of adjustment here, I think. Do I have the ability to draw lines? Maybe what I can do is draw a rectangle on the side to sort of denote the panel area. That's what I'll do. And I'll make that like a light gray. Something in that area. Okay, so in the HUD section, define HUD width 300. So before I do anything else, and in fact, I think I may need to move this stuff to like a draw HUD function now because it's starting to get a little bit more involved. So let's go back to the HUD section. Define render HUD and renderer. Okay. And first of all, we're going to do a rect draw for the HUD itself. So we're going to start at window width minus HUD width. The Y position we're going to start at is 0. We're going to end up at window width window. And the Y position we're going to end up with is window height window. And then we're going to use the HUD color, which we've picked to be 92, 87, 85. 92, 87, 85. Let's add some spaces in there. We need to also call render HUD. Ugh, that is not the right color. Must have typed it wrong. Also, I'd prefer it to be slightly wider. Oh, no, I forgot to change this HUD color. Okay. And we're going to make this be 350 instead. All right, that looks... maybe it could be not so wide. But I also need to make the playable area be that sliver in the middle and not let things go under it, I think, so that they don't get obscured. Let's see. Okay, I like the width of that better. Updates to whatever I make the window size, but we actually don't want it to do that. I would prefer if it's scaled, but it doesn't scale right now, so And why are we not seeing the other one? Where did the other... Why are we not rendering the other rectangle? Renderer, window width, window height, energy meter. Oh, what happened here? How'd that even happen? All right, there we are. Maybe I can move these over slightly. So let's say I want to center them inside of the HUD. If I do that, then this needs to be 200, let's say. And this needs to be 145. I think this is going to be slightly off, but we'll adjust it. Yeah, it's a little bit too far over. Minus 200. This needs to be minus 180. And this can be I subtracted 20, so 125. Better to do this based on math, but for now I'm just sort of eyeballing it. 90. Whoops. No. Yeah, 90 and 35. All right, that's better. Not perfect, but better. So we've got a basic HUD rendering, which is cool. Basic HUD. We're gonna make that done now. Can I set it done? Come on, there we go. And we'll check that code in also. However, I'm not going to push that yet because I realize I need to adjust the playable area of the screen based on the HUD width. I wish I could have a better handle on the size of the window because my window manager is not cooperating when it comes to window size. It just basically makes it whatever it wants. The window size. You can see it starts off as like 1320 by 960 and then scales it to 1320 by 1298. I'm asking for 1280 by 720, if that tells you anything. I don't know why it does that. Okay. So the next thing we should do to make a game work is do some collision detection for bullets. And then we can start doing things like, killing enemies and also harming the shield of the player. Another thing we need to do is add the depletion of energy over time to say whether you are losing or not. So we have the energy amount. Excuse me if you can hear me chewing. I have to eat something here. So player energy amount. So how will we update that over time? We have update player, right? Okay. So as time goes on, we're going to increment. Okay. Define player energy depletion. So in terms of time, like how long would it take for the entire meter to get depleted? $10 You would have to be doing some stuff to succeed. And we might want to reduce that depletion or increase the depletion rate as the levels of the game go on to make it a little bit more challenging. All right, so player energy depletion as a rate, we want to say that per second, because we're using time step here. And we're going from 0 to 1. So maybe let's say 0.005. Let's just start with that. We're just going to pick it out, and we're going to start editing or setting the player energy amount based on that. Player energy amount minus player energy depletion times time delta. Set player amount, player energy depletion, time delta. Okay, so deplete the energy. And then update player position. Let's see if that does anything. Oh, haha, what is this thing doing? Yeah, I've got to add that, right? No. This is wrong. Multiply, first of all. We're going to subtract player energy amount. Yeah, that seems right. And let's do that. Okay. Moving very, very slowly, which is fine at this rate of the game, I think. So you can see this meter is just gradually going down. So at some point, that's going to be 0. Maybe I'll bump it up a little bit. How about a 1 here instead of 0.5? How fast does that seem? Okay, that seems pretty reasonable for early phase game. But it doesn't really give you an incentive to do something. I guess if you start playing the game the first time, you're going to want to just learn how to shoot and move around. Boom. All right. Cool. So we got that. That's one game mechanic we've started to implement. Now, collision detection. Let's see if CGLM gives me anything for that. I think it does. CGLM. Let's see. Bounding rect. Bounding box. Okay. That's what we want. AABB collision detection. I don't feel like writing that myself right now. That's for calling. I don't know if we can just use it generally. Documentation. Here we are. So, bounding box. Here we go. Axeline bounding box. 2-dimensional array of vec 3. First is the min point. Second one is the max point. Transform, merge. Okay, frustum planes. Not what I'm looking for. Invalidate. Size, radius, center. Okay, check if 2 intersects. That's the one I would want here. GLM, AABB, AABB. Ooh, AABB intersects with sphere. That's kind of cool. You know what? I wonder if spheres are going to be better as a collision box. That way, the actual bullet collision detection is going to be a little bit closer to the body and not sort of like out on the corner. I think that could be good. So if we use spheres instead. Trying to think of how I would put this together. So who needs to do collision checking? Player checks against enemies and bullets. Enemy checks against bullets. But maybe the enemies should check against the player. I'm trying to think of the most efficient way of doing this. So maybe when we do the enemy checks. Yeah. So every bullet will be checked against every entity. And enemy checks against, okay, so bullets check against entities. And enemy checks against player. Which one is going to be less? Probably there's going to be less, well, hard to say. Yeah, we'll just go with one approach and just stick with it. So if the enemy ship collides with the player, then it hurts the player and the entity and the enemy probably. So the player doesn't need to do any collision checks. The checks will come from somewhere else. So then for update bullets, let's just start with that. Check for the collision. Check for sphere of bullet versus, okay, sphere of entity. And we're going to have to look at all entities. So that's the player, including all enemies. So if I were to use this sphere API, merge, okay, sphere, that's the collisions of two, if there are two spheres intersect, love it, that's great. This is a vec4, so maybe I just have a function for creating a sphere. That's pretty easy. So that would be in the substratic library. Where would that be? Maybe like a collision library. Let's try that. So depths, substratic engine, source, collision.c. We're going to do a collision.h also. Excuse me. Render.h. Drop this in here. Rename. Oops, let's not do that. Let's rename this to collision. Then endif. Go back into renderer. Let's rip off the module init function, because that's pretty much all we need here. Render module init, collision module init. Let's go to lib.c, add that in. Add the collision module. We need to also include it. Okay. And we need to also include mesh.h here. Now in collision.c, wait, I put this in the wrong file. That's great. Collision.h, drop that here, go back to collision.c, include collision.h, and then I'll go into render and steal the init function for the module. Collision module init, need to change this to substratic collision. I mean, I guess physics is a better name for this, but let's okay, we'll do this. Physics. Yeah, I like that better. Okay, now make sphere, maybe. Physics make sphere. So that's going to give us a sphere. And then sphere collision question mark. Or what would you call that? It's not collision. It's intersect. Sphere intersect. Okay. So we need these two functions. First of all, it's going to be value. Well, let me just go grab the actual signature from render.c. So we have what we need. We'll want that too. Okay, so physics make sphere. And let's see. We need to create one, actually. Collision.h. Type def struct subst sphere. Now, we're going to want to update the centers of those. It's going to be float center x, center y, z. Oh, don't need that. That's okay. And then the radius, float radius. Now this is radii. Okay, it's just a float. Okay, fine. I'm gonna call it radius. Okay, now if I go back into this, I can say subst sphere, sphere, size of sphere. And then sphere center x equals. We'll delete that part. Same thing for y. Going to be arg1. This one was z, which is going to be 0. We're just going to say 0 for this because we don't need anything special. And then the last is the radius. Okay, and then we're going to throw sphere out here, sphere. That all looks good to me. Now sphere intersect. We're going to do the same thing. We're going to just grab this function, sphere intersect. And we need to grab two spheres. So we're going to have sphere 1 as pointer args 0 pointer, and we're gonna have to cast that to subsphere. Subst sphere. All right, and then sphere 2. And then we're gonna return a bool val that is a result of calling this glm sphere sphere. It returns a Boolean. So that is glm sphere. No, is that right? Yeah, sphere sphere. And we're passing in only those vectors. So I think it's a pointer to a float. So we can say float star sphere 1 and then float star sphere 2. And we also need to pull in the glm header here, I believe. I think it's include, well, let's see. Let's go to render.h. Yeah, that one. All right. So in theory, this should compile. But before I do that, let's rename these files again because I decided on a different name. Let's also change this physics. This will be physics. All right. So collision, we're going to rename this to physics.c. And we're going to rename this to physics.h. Let's make sure there's nothing here called collision. Okay, got to change this. Physics. Physics. P-H-Y. Yeah. Subst physics. All right, good. Now I need to go into my project.msc and then add that as one of the files for this project. Oof. Now we're going to build it. Okay, I don't know if it did anything. Seems to have compiled it. That's good. So what we'll want to do is create spheres for the various entities as we create them. So in main.msc, we're going to go pull in this substratic physics library. Hold on a second. I think I did not go update lib.c. Surprised I didn't see an error about that. What did I do wrong? Did I mess something up? Font.h. Ah, that's what happened. Okay. Font.c. Let's go find the module init function here. Go drop this in. This is unrelated issue. Undefined reference to subst physics module init. The linker didn't find it. Oh. That's weird. Undefined reference. And in physics.c, must be the typo, of course. Physics. I think I'm starting to lose consciousness here. Okay, so now in main.msc, I'll go to player. I need to start wrapping this stuff in record. But for now, let's say player sphere make sphere. We'll start that. Ooh, okay. So that should actually be the player X position. And center Y would be player Y. And then radius is going to be, so is radius, diameter is radius times 2. So it's going to be like divided player size by 150, I think. Cool. So that's a sphere for the player, and we can use that for collision checks. Now for bullets, make bullet. Let's find the record type here. And then for the bullet, we're going to set the sphere. Yeah, make bullet, X and Y positions, velocity Y. And for the sphere, we can paste in a make sphere here. Pull in that X and Y. And every frame, we're going to have to update that center, because otherwise the checks won't work. Do we have a size somewhere? Bullet size. Okay, so we'll do that for now. Bullet size. We need to do the same thing for spawns. So then we're going to need a field here for sphere. And then when we spawn, sphere, X and Y, ooh. Okay, I'll probably have to do this then. I'm going to have to do a let here. X is this rand int. And then Y is negative 100. So we'll say X and Y. And then the size is 100. Size 100. I'm doing something wrong here. Okay, so radius. Anytime I see radius, let's divide it by 2. So everything should have a sphere now. Let's just check that. Make sure it runs. Okay, so nothing crashed, thankfully. Okay. And now on bullet updates. Where is the best place to put this? Okay, first of all, yeah, bullet updates. Update bullets. One of the steps here, okay, we move the bullet. And then set the sphere center. And we're also going to have to do something where we center the drawing of the rectangle on the position. So that's one thing we're going to have to change a little bit. But that's fine. Bullet, sphere, bullet, sphere, center. Wait, hold on. I don't have a function for that yet. I'll have to do that. Okay, so we're going to set the sphere center Y to bullet Y. Bullet. Same thing for X. Bullets can go in multiple directions, so it's better to go ahead and just set everything. So set the sphere center. And I need to add functions for that in physics.c. So, oh wait, hold on. Sphere center. Okay. Okay, let's do this. All right, so we got the sphere. And then we also need the center value. I'm just going to return, well, let's return the value that is being sent in. I think that's probably something to do here. So sphere center X equals as number args 1. And that should be good enough. Do the same thing for Y. Okay. No crashing. That's a good sign. Now, we will... Our premise says, to help cut down on spelling mistakes, have you considered using hippie expand or deabbrev? Yeah. Doesn't happen super often, though. But it might speed up my typing a little bit if I did that, probably. All right. Let's do some collision checks. So I'll have to do another named let. Let next enemy. Enemies. Enemy list. If pair enemies. Begin. Ooh. That's going to be a whole other update. It's almost like I need a reduce function or something to generalize this pattern. Because if a collision happens, then the enemy needs to go away. Or at least the shield value needs to go down. Okay, so maybe... Okay, let's just leave it like this. That's fine. Next enemy begin. So we have sphere intersect if... Can I hold on? That's fine, whatever. I'll have to make this a little bit faster, but I'll do that when I need to. Bullet, sphere, bullet. Enemy, sphere, car, enemies. And if it does, I'll just say that it's intersected. Display hit an enemy. And we also need to see if bullet owner the bullet is player that is a field, right? Owner? Yeah. Right, okay. Then we will, excuse me, that'll be the only time we'll check this enemy list. And then we need to finish this off by calling next enemy. Cutter enemies. Okay. Let's see if this works. Uh-oh. Expected 4 arguments, but got 3, line 85 in script. That's not the right one, is it? Ah, yes, it is right. I need to have an owner here, so player is the owner. Okay, there we go. Let's see if an enemy shows up. Let me get down here so we can see it. No collision. Not seeing anything yet. But I need to check, though, if we're actually doing anything. Intersect. Display. Checking collision. Make sure it's actually doing something. Nope. Nope. Okay, so it did check collision. It seems to be working, our premise. Oh, man. Okay, so sphere intersect is not doing anything, or it's not returning anything yet. We have bullet sphere, bullet, and the car enemy sphere. I set that up right. Let's do some displays here. Bullet, bullet. Then do the same thing for the enemy sphere. All right, let's try that out. Seems legit. Ah, and it only checks for collisions against the actual number of enemies. That's good. All right. Let me double check what's happening in this function. GLM sphere, sphere, sphere 1, sphere 2. Somehow it's not happy. I'm not updating the... Okay, I think I'm not updating the enemy sphere. So on main, update enemies. Let's see, sphere set. Okay. Let's try this now. Hopefully it works. Still nothing. X and Y set. Let's print some things out here. Printf new center. This is going to be very spammy. Okay, that seems legitimate. Let me print out the result of this function then. Is that right? No. Badge says, anyone else think that the theme is really difficult to think of an idea for? The way that I approached think of an idea is I thought of a kind of game that I would like to make in general, and then I decided how I would make the theme apply to that. So that's the approach that I took. And it seems a little bit more reasonable than trying to come up with an idea strictly based on the theme alone. Yeah, still like zeros. I don't get it. Check if two spheres intersect. Sphere, other sphere. Something's wrong here. Hold up. It's because I'm doing this completely wrong. Make sphere is not a record type. That's why this is not working. I'm pretty sure. Okay, any other make sphere calls? We need to get these out of here. That's what the problem is. I bet it'll start working after this. Yep, wrong. Let's try this now. I should also take that, well, okay. Let's just do it and see what happens. Hey, haha. All right, so physics, let's take this. Oh, excuse me. Let's take this collision out. Boom. I should have hit the enemy right there. Oh, it didn't. That's strange. Ah, okay. It did. It's just the printing is not being flushed. Hit an. There we go. So what I want to do... I think we're almost ready to remove an enemy. So let's try this really quick. Set or do I have shield? Define record type shield. Okay, so enemy shield set. Enemy shield. I really should pull this into a function, but let's just do it this way for now. Enemy. I also need an enemy here. And the type of bullet, maybe I should say how much damage the bullet has. Define record type damage. So the, excuse me, the drone has a shield of 10. So I want one hit to kill a drone. So let's make the default bullet shoot bullet. That sounds good. So 10. But I should make that a variable. Default bullet damage. How about that? Where's the bullet stuff? All right. There we go. So now we have that. We have damage factor. Now we can say intersect enemy shield minus the bullet damage bullet. And if the bullet hits somebody, yeah, we got to figure out the right way to do this logic. So if the bullet hits somebody, the bullet should also go away immediately. Well, let's say make bullet go away because the enemy will take care of itself. And update enemies. We update the enemy, then if enemy shield enemy is greater than 0, there we go. Then it will just get removed from the list. That's probably good enough for now. How about this? Let's go back to intersect. Enemy shield set, enemy minus. We're going to subtract the bullet damage from the shield. So let's see if that actually works. Oh. 168. Ah. Yeah, okay. That's right. Let's see what happens. Boom. Oh, it crashed. Undefined variable enemy. Ah, right. Okay, so intersect. I didn't actually hold on to the enemy, so I'm going to have to do... Ugh, I don't like this. Car enemies. There we go. Boom. See ya. Boom. Oh. Okay, so I think the radius is wrong. Maybe it's fine. Alright, so I'm killing some enemies here. I just don't have the bullets going away. I'll have to figure that out a little bit later. They're taking their sweet time to show up. You know what? I bet one was under the HUD here. I still need to fix that whole problem. Alright, so that's working. Okay, how do I make the bullet go away? Bullet alive T. Begin. Bullet alive nil. Okay, and then we can say and. Oh, what just happened? So if the bullet collides with an enemy, it should disappear. Boom. Okay, so that worked. Weirdly, the first bullet I shoot, somehow it doesn't seem to connect with the enemy. Or maybe it's just a matter of the radius not being correct. Oh. Okay, how about this? For make sphere. Okay, sphere radius. Equal to the diameter divided by 2. So diameter is supposed to be the actual width. Yeah. Oh, that's why. Okay, so render enemies. Do I have a centering for that? Hmm. All right, so I need to do the same thing for rendering the bullets. So I'm basically centering the position. This is not the most efficient way to do this. This should make things seem more accurate, though. Where are you? Come on. Okay, so that killed that one. Let's see. Right about there. Boom. Okay, that worked. Boom. Cool. I think that's working well. So I should probably like have a score that I update based on enemies that you're killing. I just haven't gotten to that yet. Okay, so I think I'm gonna wind down the first stream for the day. We made a lot of progress. I'm really happy with the progress we've made so far. Very, very pleased with what I'm seeing. So let's go and edit the README. Got that working. Okay, so what do we need to do? Add a score display, update score based on kills. Add player shield damage. Speed up the enemy spawning. I think it's a little bit slow at first. What else so far? Make enemies, well, restrict gameplay to the visible area, sans HUD. Because I think we're having a little bit of a problem right now with that. So here's the plan. Let me just commit the stuff first, and then we'll talk about it. Okay. And then I'll go to depths, substratic engine. I need to add the okay, got that. New physics library. And then we can go ahead and commit this. Add initial bullet enemy collision detection and damage. And I also want to say in the README, the org file, let's actually come up with another type of enemy that has a little bit more interesting patterns. Create another more interesting enemy with more health or more shield, because we want to see if multiple bullets will kill them. All right. I'll push that up. Okay. So here's what we're going to do. I'm going to take a break for a couple hours to take care of some responsibilities, go have some lunch, and then I'll come back, let's say around 1 p.m. my time. So right now it's 10:44 a.m. So that's going to be 12:01. So it's like almost 2 hours from now, like 2 hours and 15 minutes from now, let's say. So if you're still interested in watching what we're doing here, then please come back then. I will schedule the stream, so you'll see the stream come up on YouTube or Twitch before I actually start streaming, so you'll be able to see when it's coming. And then if you have notifications turned on for the channels, then you'll be able to see when we go live. But we will be doing another stream for about this many hours, about 3-4 hours this afternoon. And hopefully we'll get more of the game logic done. I would like to get to a point today where we have the basic game flow where you can go from 0 to finished playing a full level of the game. And then, you know, you either win or lose. That also requires that we get the energy siphoning mechanic working, which is something that we'll work on a little bit later. But yeah, if we can get the basic game loop working, then tomorrow we can do graphics for the game so that it's not just squares. And then maybe by the end of the day, we'll have something that looks like a game that's playable. So pretty excited about that. Thank you all for being here. There's more people than I thought would be watching. So I appreciate you all who have stuck around and watched me do this. And yeah, we'll see you in a couple hours. Until next time, or until I see you a little bit later, keep it creative. All right.